What if you could travel through time, to a past long forgotten, or a future yet to be written? What if the ticking clock wasn't just a measure, but a doorway? Time, the unseen river we all drift along from the moment we are born until our last breath. But what is time? Why does it move forward? Can we reverse it, pause it, leap across its flow? For centuries, philosophers, mystics, and scientists have sought the truth about time. Some saw it as divine, others an illusion. But in the modern era, science, especially physics, has brought us closer than ever to understanding time as a physical dimension, as real and malleable as the space we walk through. In this epic journey, we'll dive into ancient myths, Einstein's theories, modern quantum mechanics, paradoxes of time loops, and the most daring concepts of time machines ever imagined. Join us as we unlock the secrets of time travel. Time travel is not a modern invention. In fact, humanity has been obsessed with time for millennia. Ancient stories from across the globe contain references to time manipulation. In Hindu mythology, the Mahabharata tells of King Kakudmi, who travels to heaven to seek counsel from the god Brahma. What seems like moments in the divine realm turns out to be centuries on earth. In the Islamic tradition, the Isra and Miraj describe the Prophet Muhammad's night journey, where he travels vast distances and ascends to the heavens, all in what seems like a single night. The Bible, too, hints at divine manipulation of time. The book of Joshua describes the sun standing still to allow the Israelites to win a battle. The idea of time pausing or bending to divine will is ancient, rich, and widespread. These early narratives reflect a deep-seated fascination with the flow of time and a yearning to understand or even control it. The scientific approach to time began to take root during the Renaissance. Isaac Newton in the 17th century introduced the concept of absolute time. He believed time flowed uniformly, like an ever-ticking cosmic clock. But Newton's time was passive. It simply passed. Enter Albert Einstein, the revolutionary who flipped the script. In 1905, Einstein introduced special relativity. One of its core insights? Time is relative. It can slow down or speed up depending on how fast you move. The faster you travel, the slower your clock ticks, relative to someone at rest. This was not a fantasy. It was proven with atomic clocks on jets. Later, with general relativity, Einstein showed that gravity also affects time. The stronger the gravity, the slower time moves. Near a black hole, seconds could stretch into hours. Space and time were no longer separate. They were intertwined in what he called space-time. One real method of time travel is traveling forward in time by using time dilation. Imagine an astronaut named Maria boards a spaceship and travels near the speed of light to a star 10 light-years away. From her perspective, only a few years pass, but when she returns to Earth, she finds that centuries have gone by. This isn't science fiction, it's a consequence of Einstein's equations. In 1971, the Hafele-Keating experiment put atomic clocks on airplanes and compared them to stationary ones. The flying clocks came back slightly younger. The faster you move, or the stronger the gravity you experience, the slower your personal time flows. So, yes, travel to the future is possible right now. We simply need enough speed, or a powerful enough gravitational field. But what about the past? Backward time travel is where things get complicated and weird. One of the most famous thought experiments is the grandfather paradox. Suppose you go back in time and accidentally prevent your grandfather from meeting your grandmother. That would mean you were never born. But if you were never born, how could you go back in time? This paradox reveals the logical contradictions of past time travel. Some physicists, like Kip Thorne, have explored possible ways around it, suggesting that the universe might self-correct to prevent paradoxes. This leads to the idea of Novikov's self-consistency principle, which argues that events in time are fixed and cannot be changed, only fulfilled. Others argue that multiple timelines exist. You change the past and you branch into a new timeline, leaving your original untouched. If you could bend space, you might bend time. This is where wormholes come in. Imagine the fabric of space-time like a sheet of paper. Fold it in half. Poke a hole through it. You've just connected two distant points. That's the essence of a wormhole. First proposed by Einstein and Rosen in 1935, wormholes could, if stable, create shortcuts through space and possibly even time. Theorists suggest that if one end of a wormhole is accelerated and brought back, the time difference between the two ends could allow backward travel in time. However, we have no experimental evidence for wormholes. And even if they exist, they might be too unstable or tiny for human use. Still, in theory, they remain one of the most fascinating possibilities for time travel. Quantum physics, the physics of the ultra-small, introduces even stranger possibilities. In the quantum world, particles can exist in superpositions. Time at this level may not even flow in one direction. Some theories suggest that time could emerge from entanglement, or that past and future are linked by retrocausality. The delayed choice experiment, proposed by physicist John Wheeler, shows that decisions made in the present can seemingly affect the past behavior of particles. Then there's the many worlds interpretation. Every decision spawns a new universe. Travel back in time and change something, you've created a new branch. In this view, paradoxes disappear, but so does the idea of a single linear history. Stories of time machines have fueled our imaginations for centuries. H.G. Wells' The Time Machine, 1895, is the cornerstone of time travel fiction. In it, a Victorian scientist travels to the distant future to witness the end of the Earth. From the TARDIS in Doctor Who, to the DeLorean in Back to the Future, to the Time Turner in Harry Potter, fictional time machines come in many forms. While impossible by today's standards, these stories reflect our deep cultural fascination with time. They explore love, loss, regret, destiny, and hope, all through the lens of time. Fiction often inspires reality. Who's to say what science might achieve in 100 or 1,000 years? Beyond the grandfather paradox, other mind-bending problems arise. The Bootstrap paradox. What if you travel back in time with a book and leave it there? Someone finds it, publishes it, and eventually you read it, then take it back in time. Who wrote the book? This causality loop creates objects or knowledge without origin. Then there's the predestination paradox. Every action you take in the past ends up fulfilling what you tried to prevent. Solutions? Some physicists say such paradoxes prove backward travel is impossible. Others argue that the universe has a way of maintaining consistency, preventing changes that break causality. And yet, quantum theory might offer workarounds. Through entanglement, probability, and branching timelines, we might dodge the logic traps of classical time travel. Could time travel become reality? Today, time travel is real in a limited sense. Satellites in orbit, moving fast and experiencing weaker gravity, tick slightly differently than clocks on Earth. GPS systems must account for this. But true sci-fi style time travel requires breakthroughs in energy, engineering, and theoretical physics. If wormholes exist, and if we can stabilize them with exotic matter, we might build a real time machine. If quantum gravity is unlocked, we might finally unify time with space, matter, and energy. And even if physical travel through time proves impossible, the simulation of time, virtual time travel, may let us relive or explore other eras in immersive detail. The journey into time is far from over. Perhaps one day, someone watching this video will be the one to unlock it all. Until then, time flows on, forward unstoppable. But maybe, just maybe, not unchangeable. Could time travel become reality?